Just a minute, guys. I'm checking the streaming thing here. For a few minutes, I will be showing the questions. Yesterday, in the previous class, we have started with the concepts. We understood the concepts related to whatever the concepts are there in this units and dimensions chapter. So we understood what's a physical quantity, what are the units of a physical quantity, what are the types of physical quantities, and what are the standard units we have, how the standard units are defined. We understood what is the definition for meter, what's the definition for kilogram, so what is the definition for second, and so on like that. So majorly we can expect a question from meter, kilogram, second. So I request you all to remember the formula or the definition which is given for meter, so including temperature here, meter, kilogram, second, and Kelvin. So Kelvin is 1 by 273.15 times of the triple point of water. So what is triple point of water and everything you will be getting to know in thermodynamics. So right now you don't need to worry about that one. It's like boiling point is there, just like freezing point is there. So there is something called as triple point of water. So triple point of water is defined with respect to some pressure and everything. So 1 by 273.15 times the triple point of water is given by Kelvin. And these physical quantities are classified into fundamental physical quantities and derived physical quantities. So we can understand the difference between fundamental and derived, because like fundamental or cannot be separated into any more physical quantities. So these derived physical quantities can be separated. Force can be separated as mass and acceleration. Area can be separated as length into breadth, and so on like that. So derived physical quantities, fundamental physical quantities can be understood from these two slides. There are another type of physical quantities which are given the name as supplementary physical quantities. Primarily they are not falling into any of the previous two categories. That's fundamental physical quantity and derived physical quantity. So these are given with the names plane angle, solid angle, etc. And we understood about the requirements of the units and different types of units we have. So different types of units are CJ system, FPA system, MK system. So these are used at various locations around the globe. And in a conference in 1971, executives from various countries, scientists, etc. have decided that let's avoid confusion and use a uniform system of units, which they gave the name as international system of units, SI units basically. So they did not produce a new system of units, but just took the best units for different quantities, physical quantities from various systems. Like for example, for mass, the best one is taken as kilogram, or predominantly used one is kilogram. That's why it is taken as kilogram. For length, it is taken as meters. For time, it is taken as second, and so on like that. So that is what internal system of units are taken, and you can see the units for all of them here. Electric current is given as ampere, amount of substance as mole, luminous intensity is taken as candela, and so on like that. So once you know the units for fundamental physical quantities, you can get for derived physical quantities as well. So because area is combination of length into breadth, or pi r square, so everywhere length or some length parameters is squared up there. So area will be coming out with the units as meter square. Volume will be coming out in the units of meter cube, and so on like that. So force you can write down as newtons. Newton is the name given in these internal system of units here. So if you write down in kgs, meters, etc. So force is mass into acceleration. So force mass is having the units as kgs, and acceleration has the units as meters per second square. So force can be written also as kg meters per second square. But kg meters per second square is given the name to maintain the uniformity and simplicity as Newton. So instead of using kg meters per second square, you can use it as newtons. Angle is radians, please remember that one. And also remember that like in our day-to-day life, we may generally use different units. For example, like angle, it is in degrees. For distance, it is in kilometers, and so on like that. But the standard units are actually for units of angle as radians only. So whenever you substitute these numbers in any formula, substitute in radians basically for angles. Similarly, force is given the units as Newton. For energy also they gave the units as joules, and power it is given as watt. So these are all named after scientists, the predominant scientists there. So energy, if you take it, it is equivalent to work. So if it is equivalent to work, so you can take it as force into displacement. So units of force, we can take it as kg meter per second square, and displacement, so kg meter square per second square. So kg meter square per second square is given as joules. Similarly, if you take power, energy per time, right? So kg meter square per second. So kg meter square per second cube. You are getting a point here. So instead of writing in a lengthy way, these names are given here. So instead of using kg meters per second square for force, use it as Newton. So instead of using the kg meters seconds units for energy, use it as joules. Similarly, for power, use it as watts. So that is the advantage here. So SI units have given us these names. So before 1971, there are no units like newtons, joules and watts. So everyone was using the kgs, meters, seconds, or their own system of units itself. And we discussed about multiples and submultiples. So majorly you have to keep in mind regarding mega, which is 10 power of 6, giga, which is 10 power of 9, tera, which is 10 power of 12. Fine, clear. And in submultiples also you need to remember, like micro means 10 power of minus 6, milli means 10 power of minus 3, nano means 10 power of minus 9. So remaining things, pico, femto, etto, etc., zepto, etc., are not used much, so no need to worry about that. And we discussed about dimensional formula as well. So the terms which are all same, length, breadth, radius, thickness, etc., though they are different in English, but they are same for physics. So they are clubbed as length. Similarly, seconds, minutes, hours, days are clubbed, or basically just different in terms of English or the way it is used in our day-to-day life. But if you see, they are basically time itself, right? Understood? So these are clubbed, and we have understood that these fundamental quantities can be given with some dimensional formula. So once you give a dimensional formula for fundamental quantities, automatically you can give for derived physical quantities as well. So for length it is L, for mass it is M, for time it is T, and so on like that. So using them, yesterday we just invested good amount of time to write down the dimensional formula for these derived physical quantities. For area it will come as L square, for volume it is will come out to be L cube, and so on like that. So we have discussed in detail. I hope there is no confusion related to that one. So today we are going to discuss numericals. So whatever question comes from these things, you should be able to answer them. Clear, guys? So let's go ahead. So the last concept we discussed yesterday was this principle of homogeneity. This says that whatever equation you take, whatever equation, mathematical equation, physics equation, chemistry equation, any equation you take, whatever units are there on the left side, the same should be there on the right side as well. Automatically, when the units are same, dimensional formula will also come out to be same on the left side and also right side itself. Fine, that's the principle of homogeneity statement here. So let's start the numericals. One thing you have to keep in mind when you are preparing for competitive examinations like SSC, CGL, combined deferred service examination, that is CDS, AFCAT, etc. So though concepts are discussed at some level, you can always expect some new type of numerical. Some questions which are from basic 9th class level, some questions which are from 8th class level. Okay, so we will invest today's time in solving as many numericals as possible. So for every slide there are 4 questions here. I request you all to take some time. So I'll give you 3 minutes to try all these 4 questions here, and later I'll be automatically increasing speed. Don't worry about that one. So I request you all, it is 9:13 now here, so I'll wait till 9:16, then I will discuss the questions whichever are there on the screen here. So come on everyone, try this. I know answers are also visible here. Come on, try it everybody. So let's start the numericals. Those are easy questions, or some of the questions may be easy, some of the questions may be tough. But here what you need to understand for these examinations is you need to get the correct answer. You need to answer it and go very fast, and you should solve it very fastly, because you're competing with some lakhs of people here. So if you are actually solving it correctly and going fast and completing it very fastly, then you'll be staying ahead of the competition. Primarily to achieve that, your concept should be clear. So that's the objective with which I taught the yesterday's class. I explained you all the basic concepts. You know what is a physical quantity, you know what is a unit, what is the definition of related many concepts and all those things there. You need to understand that people think that just mugging up numericals can help you to get marks in the examination, especially for this SC, whatever the competitive examinations we are trying. But actually the reason is, unless you don't know the concepts, you will not be able to get the correct answer every time. So once you know the concepts very thoroughly, no matter whatever type of question comes, you'll be able to solve them. So let's look into these here. These questions. Mass is the measure of how much blank is in an object. So you can see the density, weight, gravity, force, all of them are irrelevant here. So if you don't know what is the correct answer, you should be able to eliminate the wrong answers here. So mass is the measure of how much density is in the body. No. Mass is the measure of how much weight is in the body. No. Okay, understand? Clear? So mass is the measure. So mass actually measures what? What is the matter? Matter means what basically? So what are the molecules? What are the atoms, neutrons, protons, electrons? So these properties. So this matter, how much matter is there inside a volume of a body, is actually given by mass. That's why it is given as the correct answer is C here. So mass is a measure of how much gravity is in an object. No. Mass is the measure of how much force is in the object. No. So you can understand that it's matter here. So this is a very basic definition which you study in your school level regarding mass. So I believe you are clear about it. If you have confusion, you can understand from this. So there is no point in going back and going through all the basics of 9th class, 10th class, etc. So whatever basics we studied now, they are sufficient. So remaining things we can revise from these questions itself. So let's go ahead with the second question now. Weight is a measure of the force of dash on an object. So basically weight, though we think weight as 20 kg, weight is equal to 40 kg in our day-to-day life, that's actually wrong, because weight is the force with which the body is pulled towards the earth. So weight is proportional to mass. More is the mass, more will be the weight, because we know weight is equal to mass into gravitational constant, that is 9.8 meter per second square. So more is the value of mass, more is the value of weight. So weight is basically a force, mass is basically mass, right? So weight is a measure of force with which it is the gravity force acting on the body. So the answer is D here. So weight is a measure of the force of density on an object. No. So weight is a measure of force of mass on an object. No. So you can understand that other options are not fitting properly at all. So gravity is the thing here. Always remember, weight is related to gravity. Let's go with the third question here. The what unit of measurement is used for mass in physics? It's a very easy one here. So just in yesterday's class only we saw different units for mass. So kilograms, grams, tons, all those are correct answers only. But liters, meters, kelvins, newtons, everything is wrong. If it is a liquid, we generally quantify by volume. If you take a 1 liter water bottle, if you pour water into that, or if you pour oil into that, though density is different, mass may be different, the amount of mass that's going there, so volume is constant there. So basically for volume we'll use liters. So don't get confused that unit of measurement for mass can also be liters there. It can be in kilograms, grams, etc., but not in liters. That's why option A is wrong, and of course option C, D, C all are wrong here, because meters is used for length, Kelvin is used for temperature, Newton is used for force. So the correct answer for the third question is B here. Let's go to the fourth question. What unit of measurement is used for weight in physics? It's a very easy one. So weight is basically nothing but force here. So here options are wrong. So liters, kilograms, meters, kelvins all doesn't fit for this respect to weight. So the correct answer is Newton here. If you think in your respective competitive examination there is no negative marking, you can go one step ahead and give the answer as B, because the most relevant one out of these four options is nothing but kilograms, because weight you should be putting in newtons. Newtons can be divided by, or whatever the force you are getting can be divided by acceleration due to gravity 9.81, and you can get the value of weight quantified in terms of mass or equivalency of mass, because weight and mass are proportional to each other just with a constant 9.81 meter per second square. Clear? So that's how you have to approximate and give the answer. Sometimes they give wrong questions, sometimes wrong options are also given there, so you need to approximate that, and if you are lucky they will be giving full marks for everybody as well. But if you are giving or going one step ahead and solving it and giving some answer instead of skipping it there, the chance of staying ahead of all the people will be very much possible, because in the examination you might have thought that options are wrong. Very rarely that will happen, so you have left the question. But if you are attempting something, there's a chance that other people can go wrong by thinking that options are wrong, but you will be ending up staying, getting correct answer, or getting little bit more marks than other people. Then you can easily stay ahead of the competition. So basically it's a race here. These examinations, SSC, CGL, CDS, AFCAT, etc., all are race examinations here. So you need to be fast, you need to be sharp, you need to be correct, all of them here. Understood? So let's go with these questions here. Again I will be giving you 4 minutes. I request you all to try this. I'll give you 5 minutes because there are 5 questions here, and when you are preparing now you might require more time, but once you get the speed over the time you will be definitely achieving very easily. So you'll be solving these questions within seconds, so we'll reach that level automatically. You don't need to work separately for speed. All you need to do is just try to concentrate on accuracy. That means whatever questions answer you are ticking, that should be the correct answer. Concentrate on quality now, automatically speed will come little later. So for me the time is 9:25 here, so I will give answers for these questions at 9:30. Come on, try it, and I request you all to prepare for the concepts very thoroughly so that you can give the answers for these questions in a more correct way. So let me give explanation for this for these 5 questions here. Which method of determining mass involves measuring how much an object resists in acceleration? So basically, here if you see the question, let's understand the question here. Which method of determining mass involves measuring how much an object resists acceleration? So if you see the options, there is inertial mass, there is atomic mass, there is gravitational mass, Newton mass, none of the above. First of all, we can eliminate option atomic mass. So the reason is we are talking about physics, we are talking about outside body, we are not dealing with the quantitative physics where we deal with atoms, molecules, etc. Right? So option B can be eliminated. Right? Next one, Newton mass. There is nothing called as Newton mass. Right? It's a simple wrong word. So option D is also wrong here. Next one, gravitational mass. Similarly, so what is gravitational mass? Nothing. Mass itself will be experiencing gravitational force there. So gravitational mass is also an irrelevant word. Right? So the option which is left is nothing but inertial mass itself. So basically, why inertial mass term is more correct, or the answer is A. The reason is basically resisting acceleration means what? Acceleration is always proportional to force. More is the force, more will be the acceleration. Less is the force, less will be the acceleration. Right? Okay. So when you are dealing with acceleration, indirectly you are dealing with force. Right? So inertia is a concept, I believe you guys remember it. Inertia means basically, if a body is at rest, like if a big table is there, a big fridge or something is there in your house, if you want to move it, it will be very difficult to move. The reason it has huge mass there. For example, a small chair is there, it has less mass, so it is very easy to move it. So basically, mass gives rise to inertia. Inertia means like staying in the same position, or if it is at rest, it will try to be at rest. If it is at motion, it will be at motion. Like for example, if you are driving your vehicle on a road and suddenly there is a lorry, you will be very careful with that one. Okay, or if a lorry is in your back, it is actually behind you, you will be a little bit careful. The reason is, you know that if suddenly you apply a brake, your bike may stop, but the lorry driver, though he might apply the brake, it might not be able to be stopped very easily. So more is the mass, then very difficultly it will be stopped. It's very difficult to stop it instantaneously, just like you stop a bike. Right? So inertia is that concept here. So the body at rest, let me more is the mass, then the body at rest will try to be at rest. It will be very difficult to bring it to motion, or if it is already in motion, then it will be very difficult there. So here we can understand from the correlation between acceleration, force and inertia that we can give the correct answer for this question as inertial mass. You need to inculcate this habit of thinking. The reason is, every time you will not be able to have correct answer, 100% known answer for every question. So you need to understand which option would be best fitting there. Fine guys, let's go ahead with the 6th question here. I believe you guys are understanding very thoroughly. If by any chance you have any doubt, I request you all to please put that doubt in the chat. I will be immediately clearing that up. Fine everyone? Okay, so let's go with the next question here. Which measurement would be different if you were on a moon versus on earth? Obviously the answer is B here. Why? How can you say that the weight will be different on moon and earth? It is coming from the formula of weight mass formula, that is weight is equal to mass into gravity. So if you take mass is 1 kg. For example, you are 60 kg here. If you go to moon, if you are participating in a ISRO mission and you are reaching moon, then also you will be 60 kg. Your mass will not change. Okay, your mass will not change. Okay, but here if you take weight, So weight is, I told you in the previous first four questions, that weight is mass into gravity. So it is basically the force with which it is pulled towards the earth, right? So when you are on earth, gravitational constant is 9.8 meter per second square, and on moon the gravitational constant is 1 by 6th of what is there on earth, that is 9.81 by 6 basically. So your gravitational acceleration is lesser for earth, so lesser for moon as compared to earth. So whatever weight you have on earth, that will be 1 by 6th when you go to on the moon there. Understood? So you should forget about the misconceptions you have in your day-to-day life. You're getting my point? So because in your day-to-day life, mass and weight are taken as same, and weight we give in terms of kg. In fact, our weighing machine is calibrated in such a way that it takes the force with which you are actually being pulled towards the earth and gives the reading in terms of mass. The scale is given in terms of kgs. So you should not be having any confusion with those misconceptions we have or we are using in our day-to-day life here. Fine? So I believe there is no confusion related to this. Let's go with the 7th question here. Very straightforward formula based question. Finish the formula: force is equal to mass into acceleration. You have to keep in mind one very important thing. In these type of questions, everybody will be getting correct answer. Very rarely the person who is very dumb or just sleeping in the examination will not be giving correct answer for this. Whenever you are giving answers to these simple questions, you should be accurately giving the answer for this. If you by mistakenly, instead of ticking C option, if you are ticking something like A or B or C, D or E, you will be losing marks and you will be staying behind the competition. So if you want to avoid that, you should be giving correct answer and you should be very careful. Clear, guys? Let's go with question number 8 here. What is the weight of a 1 kg mass object on a planet Earth? So you know weight is given by mass into gravity. Mass is already given as 1 kg. You know acceleration to gravity is 9.81 meter per second square. So 1 into 9.81 comes out to be 9.8. And you know in SI units basically here, you will be substituting G as 9.81. So when you're multiplying 9.81, automatically the force, which is weight, comes out in newtons, which is SI units here. So the answer should be 9.81, the number, and the units also should be in newtons, not pounds or anything else. So the correct answer is D here. Option B and C are in newtons only, but they are not correct here because they are not 9.81. So the answer is D itself. Clear? So I believe there is no confusion related to question number 8. Let's go with question number 9. Two objects with the same volume always have the same mass. Obviously wrong, because you take for example, you take a stone on your one hand and take a sponge of same shape or something like that on your left hand, right? So you can say that you will not be having, both will not be having same mass, right? Because stone will have higher density, that is mass per volume is very high for stone and mass per volume is very less for sponge. So sponge will be very light and stone will be having higher density, so hence higher mass will be there. So same volume doesn't mean same mass, because density can vary from material to material. That's why the answer for this question is 9. For this 9th question is B here. So I believe there is no confusion related to anything. I request you all to be clear about easy questions and also tougher questions. So we'll be discussing almost all the numericals whatever are there in the public domain for all these examinations here. Clear? So I request you all to be patient enough and try on your own and wait for my solution. Come on, take these 5 questions and try these. Please think. Please don't be in a hurry. Please think. If you think that any of the ticked answer is wrong and your answer is right, then also you can stay with that. I'll give the explanation and you can understand from that one. And if you think that your answer is right and my explanation is wrong, please feel free to put it in the chat. I'll give you where actually you're going wrong. Being a faculty who is having around 10 years of teaching experience, I can tell you where actually you're actually going wrong. So I want you people to commit mistakes, as many mistakes as possible in your preparation time here itself. You cannot afford to commit mistakes in the examination. Please understand that one. Fine, guys. So now it is 9:39. I'll wait till 9:44 and we'll be resuming the class. Achha, there are 5 questions, right? I'll give you 5 minutes. Now it's 9:40 already. I'll resume by 9:45 and give the solutions for these. Come on, everyone. Try this question. So I believe you guys have given a try for all these questions. Now let's go with these questions. So if you take 10th question, your mind will be tempting to look into 14th question or 13th question, right? That's what actually you should do in the examination. You see these 5 questions. Question 13, 14 are dead easy. 14th question, if you see, SI units of density. Density is what here? Mass per volume. Mass is kg. Volume is meter cube. So simply answer is D. So these questions are very straightforward. So actually in the examination, instead of always going in the sequence, you have to see as a whole and try to tick the answers for easy questions very fast. So you can immediately give the answer for 14th as D, because you need to put in SI units, so kg per meter cube, right? And if you see 13th question, kilogram is a unit of, it's definitely for mass itself, so it is not for weight, it is not for tension, it's not for resistance, so answer is D. So you can straight away jump and give answer 13 and 14 very fastly as compared to 10, 11 or 12 here. Again you can give answer for 11. Newton is a unit of, basically Newton is a unit for actually force. So if you see the options 1, 2, A, B, C, D, let's see whichever are the forces here. Time is not a force, speed is not force, mass is not force, but weight is a force. So weight is the force with which it is being pulled towards the center of the earth or the planet on which we are actually standing. So the answer is A. So like this we can give answer for 11, 13 and 14 very fastly, right? Now here you see another simple question. So 12th question, they are giving volume of pure water is 62 meter cube here, and mass is given as 62,000 kg. What is its density? So they gave the numbers so that we can do the division or multiplication very easily here. So density, they are asking, density is nothing but mass by volume. Mass is 62,000, volume is 62 meter cube. So 62,000 by 62, it comes out to be 1000 kg meter cube. So the answer is C. So instead of going with 10th and wasting time, you have already answered 11, 12, 13, 14 very fastly. Fine everyone? Now let's go get into the 10th question here. It's given that the law of dash of mass states that the mass of a closed system must remain constant over time. Of course it's conservation of mass, right? So because conservation of mass, conservation of energy, if you take it, they say something is constant. Conservation of mass says mass is constant, it will not change, or it cannot disappear, or it cannot directly appear at some point of time. So it is always be constant there. So conservation synonymous word is actually constant. So similarly for conservation of energy also same. Energy cannot be created nor destroyed. It can just convert from one form to other form. So clear everybody? Understood? So 10th one, the answer is nothing but conservation itself. So the law of, like if you try to put option A, B, C or D, the sentence itself will look little bit not convincing. So you should understand from that one. The sentence itself will not be looking convincing there. So fine everybody. So you have to inculcate the habit of solving the easy questions first and little tougher questions. Even if they look like they will take some 3 to 4 seconds larger or more time, you should jump into the easier questions there. Fine everybody? Clear? Let's go ahead with the next slide and let's look into the questions. So another 5 questions here. So I'll wait till 9:55 and then let's resume the class with these numericals. So again apply the same habit. Jump to easy question, tick that first, and take up the little tougher question, relatively tougher question little later towards the end of these 5 questions. Come on everyone. No worries. So I believe you guys have given a try. So let's discuss solutions, answers for these 5 questions here. So if you see, we can jump to, our eyes can jump to a question number 18 here. You might feel easy with respect to any other question as well. I just feel this particular question is of few terms, so I can say that like 18th question might be easy, so I'm jumping to 18th question here. So 18th question says mass is a measure of. So we discussed today only the first question. The same question got repeated here. So mass is a measure of nothing but matter. It's not measure of weight. It's not measure of inertia. It's not measure of friction. It's not measure. It's a measure of matter basically. So the answer is nothing but D here. So 18th question is done. Now let me look into this one here. So to convert density of kg meter cube into gram centimeter cube, we divide quantity with. So what we need to do here is, we need to convert kg meter cube to gram centimeter cube here, right? So kg, 1 kg is 1000 grams. So here you can see that like 1 kg is substituted with 1000 grams here, and 1 meter cube, every meter is basically 100 centimeter. So meter cube means 100 cube centimeter cube. So 1000 by 10 power of 6. So in the denominator 10 power of 6 is there, and in the numerator 1000 is there. So 1000 by 10 power of 6, or 10 power of 3 by 10 power of 6. So 10 power of 3 and denominator 10 power of 6. So if you simplify, it will become 1 by 10 power of 3. So that means it is D here. Understood? I believe it is clear to you guys here. Let me jump to question number 15. SI units for density. Again, we already solved this question, right? So it's a repetition here. So density is mass per unit volume. So mass is in terms of kg, volume is in terms of meter cube, right? So kg per meter cube. So if you write down by bringing meter cube to the numerator, it will become meter power of minus 3. So kg meter power of minus 3. So we're done with 15th question, we're done with 16th question, we're done with 18th question. Let's solve 17th question. So it's given that mass of oil is 11040 kg and volume is 12. So we need to get density. So density is nothing but mass per volume. So simply you should divide 11040 by 12. So unless and until the division cannot be done very easily, they will not be putting those numbers. Mostly they will give you numbers in such a way that you can do the simplification fast. So 11040, if you simplify or divide by 12, you will get it as 920, and the units will be in kg per meter cube. Kg per meter cube. So kg per meter cube means like A, B, C, 3 options are given with the same units here, but the number should be 920. So the answer is B. Done. So we're done with 17th question as well. So let's go with 19th question. So the density of a substance is nothing but mass per volume. Another easy question. So you can see that like relatively tougher questions are actually, or relatively like lengthy questions are 16th and 17. Remaining 15, 18, 19 are very straightforward. Fine guys, so we're stopping the class here. We will be continuing the class in the next one with the remaining numericals. Fine everyone. So I'll be correcting some more numericals in the next class and we'll be discussing them. So please subscribe to this subscribe to this channel and also click on the bell icon so that in the next class, whenever it is scheduled, you'll be getting a notification. So thank you so much everybody.